Prusa i3 Mark III was released in 2017, and at the time of its release it was one of the best hobbyist printers you could get. Maybe the best. It had a great, easy to use interface. It used a full-size SD card, the screen was great, the extruder used Bondtech dual drive gears, it had sensorless homing, auto leveling, filament run-out sensor, PEI bed. It was an amazing printer. Everyone bought one, including us. But it is 2024 and our Prusa is showing its age. Prusa do offer a Mark 3.5 upgrade kit, but it is around €250 and you just get a new board and screen. So maybe that is a bit too much for too little. Despite this, it does upgrade the speed, which is quite useful because this thing just crawls along compared to our other printers. I have always loved this printer. I can't part ways with it easily. I have tended it and upgraded it over the years. I mean, when I say upgrade, I haven't really upgraded it that much because it doesn't need to be upgraded. It just works. But now I might have to part with it because new printers come in and we gotta make room. But I actually want to upgrade it so I can keep it, but I don't want to change it that much because this design is great. Even now the Mark IV uses the same features. It uses the steel frame, the 30-30 extrusion, steel rods and LM bearings. It's a wonderful design. So I want to keep it as unaltered as possible, or at least keep it looking unaltered. And I'm not really that concerned about upgrading it so it has a web interface or an MMU or something. I just want it to be a little bit faster at the same quality so I can justify having it there next to me. So I am just gonna DIY the bejesus out of this printer. The Prusa i3 Mark III uses an INSI Rambo board. This is an 8-bit board. Haven't worked with one of those in a while. Processor of this board is an 18 Mega 2560. Processing speed of that is 17 megahertz. What's a Raspberry Pi again? The 4B? 1.5 gigahertz? So I guess you know what the obvious route to take here is. That's right, more Marlin firmware. Yes, I am going to keep the Marlin firmware on this machine as a memorial to Prusa and Marlin. Now I know a lot of you might be confused here. Obviously the easiest way to upgrade this printer's capability is with a Pi and Clipper. All you do is plug the Pi in, install Clipper, and well, you're basically done. But I really want to keep the Marlin firmware. Maybe it's just a sentimental choice, but it's also kind of a challenge to Marlin. Every printer that has come out recently has used Clipper, Clipper style, Clipper inspired firmware, and I get that. It works really well. It's a great firmware. But I want to keep Marlin on this machine because it also works really well with this machine, albeit with a few changes from the Prusa team. So I want to keep this Marlin firmware on it so I can see what I can achieve with it when everyone is still using these Clipper inspired firmwares. Honestly, I'm a lot more interested in what I can do with Marlin on this machine than what I can get from an FL Sun S1 printing at 1200 millimeters per second. Also, upgrading to a Pi does nothing to change the integrated hardware on that board, so I would have close to no option to changing those TMC 2130s that are integrated into the board. But if I do get a new board, well then I do have options. So that is the goal. Upgrade the printer so it can compete with the Mark IV. So what would be the best board for this? Well, it's Marlin. I can use pretty much any board, but I want one that fits it well and one that's easily changeable with added peripherals if I want to do that in future. I don't really need 1.5 gigahertz of clock speed. Just an example of what a printer can do even with a low powered board. I have an Enter 2 Pro at home and it's still using Marlin firmware. And that printer can move those motors up to print speeds of over 300 millimeters per second at 3K acceleration. After 400 millimeters per second at 4K acceleration, the motors do start to stutter. Now that printer has an advantage. The bed is small. It weighs a lot less than a Prusa bed. That main board has a STM32F103 RET6 processor. It's the same as the Ender boards 4.2.2 and 4.2.7. But the processor has a clock speed of around 72 megahertz. We can go higher than that. Not that I think this motion system can tolerate over 300 millimeters per second, but I want to give it the option and maybe in future we can change things so that it can do that. So this is the Octopus Pro board, and I got this a while ago, but I never got a chance to use it, so I'm just going to go for it. Obviously what sets this board apart is the amount of spare places for stepper drivers. We have 8 ports for stepper drivers. That's probably enough for us. The extra driver ports give us an option to add additional motors to each axis, sort of like the AWD system on VZBot printers. It also has a 48 volt power input for the stepper drivers, so if we want to use TMC 5160s, we can. Not that I think that we should in this printer's particular condition, but it does give us the option later down the road. If you are interested in upgrading the Prusa Mark III board, you definitely don't need to have an Octopus Pro board. You can do this with many boards. The only real requirement is having 2 EXP ports for the screen. So the first thing I did was to take a look at the INZ board, and this is a totally custom board made by Prusa, so I figured there would be a few compatibility issues. And the first thing I noticed about the PSU was that it only has 2 power outputs, and the Octopus board needs 3. So we need a new PSU. Next thing, all of these connections on the INZ board, they actually use Molex connectors. You just had to be different, Joseph. Pretty much every board uses a JST connector. I don't really know why they use Molex, but it means I have to rewire everything for JST connections. Basically, all of these connections have to be rewired for the JST connections, and you can get a pack of these with a crimping tool online for pretty cheap. It's not that difficult to do, but if you are new to this, I have linked a tutorial down below. Okay, what's next? So the fans are both 5 volt. Both the hot end fan and the part cooling fan are 5 volt fans. With other mainboards that might be an issue, but luckily the Octopus has ports for 5 volt fans. In fact, it has ports where you can select the correct voltage for your specific peripheral. So maybe you have a 5 volt Noctua fan, a 24 volt hot end fan, and a 12 volt mainboard fan. I don't know why you would do that, but that's not a problem with the Octopus Pro. All you do is just add a jumper to the space above. The one on the right is for 5 volt, the middle is 12 volt, and the left is 24 volt. What is interesting about these fans is that it has an extra yellow wire here for a tachometer. This is curious. We're not going to do that though. We're just going to slap on a 2-pin connector. Next are the power connectors. These little U-shaped connectors are used, which actually fit okay with the Octopus Pro. However, if you're doing this with another board, you might need to swap things. You do have some options. So what you could do is you could solder the tips of the copper wires, but that's not the best thing to do. It's the easiest thing to do, but it's not the safest thing to do. My advice would be to use ferrules, and you can get a pack of ferrules online with another crimping tool, also pretty cheap. And if you're new to that completely, then I have also linked a tutorial down below. The LCD connectors should be fine, the thermistors should be fine. The filament sensor and the pinda might be a bit of an issue, but we'll get to that. Weirdest thing about this printer that I can't believe I have overlooked for years is that the mainboard has no cooling. I have never seen a printer with a mainboard with no cooling. I guess the 2130s don't need that much cooling. Okay, that's everything, I think. Let's get to work. After wiring everything, I went back to VS Code to get the firmware ready, and I am using the Prusa Mark III config profile that you can download from the Marlin GitHub. Unfortunately, we had a couple of problems. So first was a couple of sanity checks. The first was that the auto fan pin was set to the same pin as the part cooling fan. That was pretty easy to fix, but the second, not so much. The Prusa uses an inductive probe for leveling. This is just a normal inductive probe, except that it has a thermistor built into it, which compensates for temperature fluctuations as you're leveling, which makes it a lot more reliable. Unfortunately, the Marlin config I use does not have a pin selected for the thermistor natively, so I need to change that. But also, one issue was that for some reason the signal from the Pinda probe just wasn't recognized. The Pinda probe worked perfectly, but it just wasn't recognized, and I had to select a pin specifically for that. And the other issue I had was that the logic was inverted for the pin to probe, which meant that when it was triggered, it was actually open, and when it was open, it was actually triggered, which was confusing for me. It has been a while since I edited Marlin firmware, and since then, there has been some feature renaming. So the Zmin end-stop inverting feature doesn't exist anymore, and now it is Zmin end-stop hit state with a value of low or high instead of true or false, which completely threw me off, and it took me hours to fix this, and the correct pin for the signal and the thermal compensation too. Eventually, it worked. I also learned that the screen cables that plug into the EXP ports just don't work as default. I needed to flip them, and that meant snipping the little clip on one side. Everything else went swimmingly though. Now that the basic firmware is complete, I can enable those fancy schmancy features like junction deviation, linear advance, and input shaping. Yay! Okay, so let's do a calibration cube test and see what happens. Here I have set max acceleration to 2K and speeds are at 200 millimeters per second. Okay, not bad, but we do have some work to do. So a lot of the firmware needs to be optimized, I think, and also some hardware does. These bearings feel a bit sticky and squeaky. The Z motors are fine, but the X and Y are getting a bit warm, even at 500 milliamps. I might have to replace those. I still need to enable the filament sensor, and probably most crucially is the hot end. So I'm using a standard Revo hot end, with a max flow of, I think it's 14 millimeters cubed per second. That's an issue because at the speeds that I was printing at 200 millimeters per second with a 0.4 nozzle, I can only do 0.1 millimeter layer heights. If I go to 0.2, that's just way too high in terms of volumetric flow. It's like almost 20, I think. So yeah, we definitely need to upgrade the Revo. So yeah, a lot needs to be changed here. This printer has seen a lot of use over the years, but you're gonna have to wait until the next episode until we do that. If you have any questions about our upgrade, or you'd like to suggest something that we should do to it, then please let us know in the comments below. You can also write us, and you can also join us on our Discord server where there is fun talk on a daily basis. The link is down below for that. And we'll see you guys next time. Later.